In this lesson, we're going to simplify expressions that involve rational exponents using the laws of exponents. The laws of exponents are written in this box here for your reference. We reviewed each of these laws of exponents in my 4.2 video. If we look ahead, we're going to see problems that involve rational exponents. Remember, the word rational means fraction. So in other words, we'll see fractional exponents. And the instructions will ask us to simplify. Now the word simplify seems like a very simple word, but when you're asked to simplify expressions involving exponents in mathematics, the word simplify is very specific. If you have a problem involving exponents, the instructions simplify mean that you need to check for 4 different things. We're going to review those 4 different things right now. If the instructions say simplify, that means that all exponents should be positive. So let's look at an example. If we want to simplify this expression here, we notice that there's a negative exponent. To simplify this, we need to rewrite it using positive exponents. Since this term is in the numerator, to rewrite it using positive exponents, we pick this up and move it to the denominator, and that will give us 1 over x. And when we move this to the denominator, this exponent becomes a positive 4/5. Let's look at one more example. If we're asked to simplify this expression here, we notice there's a negative exponent, so we need to rewrite it using positive exponents. Since the expression involving negative exponents is in the denominator, we need to pick it up and move it to the numerator, and when we do that, the exponent becomes a positive 3/2. So when you're asked to simplify, make sure that your final answer involves only positive exponents, not negative exponents. In addition, if you're asked to simplify, that means that each base should occur only once. Let's look at some examples. This expression is not yet simplified because the base x occurs more than once. We're going to use the product rule here. And remember, all of those laws of exponents are in this box up here. The product rule says that when you multiply 2 quantities with the same base, we keep the base and we add the exponents. So we'll take 3 plus 5, and that will leave us with x to the 8th. This is simplified because now the base x only appears once. This expression here is not yet simplified because the base a occurs more than once. To simplify this, we're going to use the quotient rule. The quotient rule says that when you divide 2 quantities with the same base, to simplify, you keep the base and subtract the exponents. So we'll take 6 minus 4, and that will leave us with a squared. In addition to these 2 things, when you're asked to simplify, there should be no powers raised to powers. In math, the word power means exponent, so you could rephrase this as there should be no exponents raised to exponents. So as an example, this expression here is not yet simplified since we have an exponent raised to an exponent. To simplify this, we use the power rule. And the power rule says that when you have a power raised to a power, to simplify, we just need to multiply those 2 exponents together, 3 times 5, and that will leave us with x to the 15th. This expression is also not yet simplified since we have powers being raised to another power. To simplify this, we're first going to use the product to a power rule. The product to a power rule says that if inside your parentheses your quantities are being multiplied together, then you can apply the exponent outside of the parentheses to each of the quantities being multiplied. So let's first apply this outer exponent to the x squared. That will leave us with x squared to the 4th. And then let's apply the 4 to the y cubed. That will leave us with y cubed to the 4th. Now, this is still not simplified because we still have powers being raised to powers. So to simplify this, we'll now use the power rule, which says when you have an exponent raised to an exponent, to simplify, you just multiply those 2 exponents. So if we take 2 times 4, that will leave us with x to the 8th. And if we take 3 times 4, that will leave us with y to the 12th. And the last thing you need to do if you're asked to simplify is you need to evaluate if possible by writing as a radical. If you end up with a number raised to a fractional exponent, you can always rewrite it as a radical. We learned how to do this in my chapter 6.1 video. To rewrite this as a radical, we start by writing the base 125 underneath the radical symbol, and then the denominator always becomes the index of your radical. And in my 6.1 video, we learned that you can write the numerator either as an exponent underneath the radical right here, or you can write the numerator as an exponent outside the radical. When you write the numerator as an exponent outside the radical, we call this form 2. And I prefer form 2 because it avoids the really large numbers that you can sometimes get with form 1 when you put the exponent underneath the radical here. Now we need to evaluate this. And to evaluate means that we actually want to compute this to find the actual value of this. First, let's work inside these parentheses here. In my 6.1 video, we learned that we want to rewrite 125 as some quantity cubed. Because if we can rewrite 125 as some quantity cubed, then the cubed root and the cubed power will cancel each other out. 125 can be written as 5 cubed. So now the rule that we learned in my 6.1 video told us that when the index matches this exponent, they cancel. And that's because the cubed root and the cubed power are inverse operations. So if we cancel this cubed root and the cubed power, all that we're left with is just 5. But now let's not forget that we were just focusing inside this radical here. We still have this outer square. So I'm going to carry over this outer square, and then I'll carry over the outer square here as well. And that will leave us with a final answer of 5 squared, which gives us 25. So, if you're working with a problem involving exponents, if the instructions say simplify, that means 4 things. All of the exponents should be positive. Each base should occur only once. There should be no powers raised to powers. And you want to evaluate, if possible, by writing as a radical. On the next few pages, we'll look at several examples. Now in chapter 6, we're learning about radicals. So why are we now looking at problems involving fractional exponents? Remember, in my 6.1 video, we learned that anytime you have a fraction for an exponent, you can always rewrite that using radicals. So that's why in chapter 6, where we study radicals, we look at fractional exponents, because you can always rewrite fractional exponents using radicals. Now the instructions here ask us to simplify. So let's start with problem number 1. Problem number 1 is not yet simplified because, as we learned on the previous page, in order to be simplified, each base should occur only once. Notice here the base 16 occurs more than once. To simplify this, the rules of exponents tell us that when you multiply two quantities with the same base, you can use the product rule of exponents, which tells us to keep the base 16 and add the exponents. So we'll take 2/3 plus 5/6. Now, if we want to add these fractions by hand, we need a common denominator. So I've just copied this expression down here, and to get a common denominator, we could use the LCD 6. So to get this denominator to be 6, we could multiply the denominator by 2, and then we also have to multiply the numerator by 2. This will leave us with 16 to the 4/6 plus 5/6. Now we have a common denominator, so now we can add these fractions. When we add these fractions, we keep the common denominator 6 and just add the numerators. 4 plus 5 gives us 9. Now we can reduce 9/6 by dividing the numerator and denominator by 3. 9 divided by 3 gives us 3, and 6 divided by 3 gives us 2. Now, to begin, this was not simplified because the base 16 occurred more than once. We fixed that. Now the base 16 only occurs once. If we look back when we're simplifying, all exponents should be positive, and we're good there. Each base should occur only once, we're good there. There should be no powers raised to powers, we're good there. But we need to do step D. We need to evaluate if possible by writing as a radical. Because when you end up with a number raised to a fractional exponent, you want to rewrite it as a radical to see if you can evaluate it. To rewrite this as a radical, we put the base underneath our radical symbol. Then we're going to put the denominator as our index. So this is a square root. And remember, when your index is a 2, you do not need to write it. So we don't have to write this 2, but just for clarity, I'm going to leave it there. And then we're going to write our numerator as an exponent outside the radical. Now let's simplify this. If we work inside the parentheses, the square root of 16 is 4, and then we'll make sure to include these outer parentheses, and 4 cubed will leave us with 64. Now we've simplified as much as possible. For problem number 2, again, we're supposed to simplify, and we're dealing with the same issue in problem number 2. Each base should occur only once. The base y occurs more than once, so we need to fix that. We can use the quotient rule of exponents, which says that when you're dividing two quantities with the same base, we keep the base, which is y, and then we subtract the exponents. So we'll take 1/5 and we'll subtract 9/10. Now, if we want to subtract these by hand, we need a common denominator. The least common denominator is 10, so we could multiply the top and bottom of this fraction by 2, and that will leave us with y to the 2/10 minus 9/10. And to subtract 2/10 minus 9/10, we keep the denominator and subtract the numerators. 2 minus 9 will give us a -7. Now we fixed the problem because the base y only appears once, but now a new problem has come up. When simplifying, we do not want negative exponents. So we need to rewrite this using a positive exponent. Since this expression appears in the numerator, we want to pick it up and move it to the denominator. And when we do that, we'll be left with 1 over y, and the -7/10 turns into a positive 7/10. Now notice, if you end up with a number raised to a fractional exponent, you want to evaluate it, meaning that you want to calculate its actual value. In order to evaluate an expression involving a fractional exponent, we rewrite it as a radical. But we only need to do that if your base is an actual number. If you have a variable raised to a fractional exponent, you can write it as a radical, but that's not going to help you to simplify it any further. So we can stop here. Again, you could rewrite this as a radical, but it wouldn't make it any further simplified, so it's not required. Let's take a look at another example here. Before we attempt this example, I want to look at two simpler but related examples. Let's suppose we were asked to simplify this expression here. There's two issues here. The base x occurs more than once, and we have a negative exponent. So we need to fix those two issues. But there's two approaches we could use. One approach is to use the quotient rule of exponents. And the quotient rule of exponents says when you divide two quantities with the same base, we can keep the base and subtract the exponents. So we're going to take this exponent 5 and subtract this exponent, which is a -2. And 5 minus -2 is equal to 5 plus 2, which gives us x to the 7th. Another method you could use to solve this same problem is to first rewrite this so that there is no negative exponent. To do that, we're going to take this expression involving the negative exponent and move it to the numerator. And when we move it to the numerator, that exponent will become a positive 2. Notice also when we move it to the numerator, we multiply it by the quantity that was already in the numerator. Now, to simplify this, we can use the product rule, which says when you multiply two quantities with the same base, we add the exponents. So we're going to take 5 plus 2, and that will leave us with x to the 7th. So notice both methods got us the same answer in the end. Let's use method 1 and method 2 to solve this problem here. So I notice that the base 8 appears more than once. We need to fix that issue. And also we have a negative exponent. When we're simplifying, we don't want negative exponents. If we use method 1, we're going to be using the quotient rule, which says when you divide two quantities with the same base, we keep the base and we subtract the exponents. So we're going to take 10 21sts and we'll subtract this exponent, -6/7. Now, subtracting a negative is equivalent to adding. So I've rewritten this as 10 over 21 plus 6/7. Now we want to add these fractions. You can either do this by hand by getting a common denominator, or you can type this into your calculator. I would recommend just typing it into your calculator, and if you take 10 over 21 plus 6/7, we get 4/3. Now we're having success simplifying. We started out with the base 8 occurring more than once, which we fixed, and we also started out with a negative exponent. We no longer have a negative exponent. But there's one more thing we need to do to simplify. If we look back when we're simplifying, all exponents should be positive, and we're good there. Each space should occur only once, we're good there. There should be no powers raised to powers, we're good there. But we need to do step D. We need to evaluate if possible by writing as a radical. Remember, if you end up with a number raised to a fractional exponent, like we did up here, we evaluate it by writing it as a radical. To write this as a radical, we start by putting the 8 underneath the radical symbol. The denominator becomes our index, and then we put the numerator as an exponent outside of our radical. Now, you might know the cubed root of 8 by heart, but just to practice the strategies that we learned in 6.1, since this is the cubed root, let's rewrite 8 as some quantity cubed. 8 can be written as 2 cubed. Now, since this index matches this exponent, they cancel because the cubed root and the cubed power are inverse operations. They cancel. So if we cancel the cubed root and the cubed power, we're just left with 2 raised to the 4th. And 2 to the 4th gives us 16. Let's see how we could solve this same problem using method 2 that we practiced here. I've started by copying this original problem over here. Now, for method 2, let's start by rewriting this negative exponent using positive exponents. And to do that, we're going to pick up this expression involving the negative exponent and move it to the numerator. And when we move this to the numerator, that will leave us with 8 to the positive 6/7. Now we can use the product rule of exponents, which says when you're multiplying two quantities with the same base, we keep the base and add the exponents. So we're going to take 10 over 21 plus 6/7. Now, this expression here is the exact same expression we have right here. We have 8 to the 10 over 21 plus 6/7. So you would want to repeat these exact same steps. I'm not going to repeat all of these same steps all over again, but if you did, you would end up with this exact same answer, 16. Now, if we look at these two problems here, the instructions are still to simplify. So let's look back at the first page. It looks like both of those problems have powers raised to powers. So in order to simplify, we need to rewrite the problems so that there are no powers raised to powers. See here we have this power being raised to a power. We need to fix that. And over here we have these powers being raised to this power. We need to fix that as well. The power rule of exponents says that when you raise an exponent to an exponent, to simplify, we just multiply those exponents together. So we took 3/2 and multiplied it by 5/3. When we're multiplying fractions, we just multiply the numerators and multiply the denominators. So 3 times 5 will give us 15, and 2 times 3 will give us 6. We can reduce this fraction by dividing the numerator and denominator by 3. 15 divided by 3 gives us 5, and 6 divided by 3 gives us 2. Now, we fixed this issue. There are no longer powers raised to powers. But remember, if you end up with a number raised to a fractional exponent, we want to evaluate it. And we evaluate quantities involving fractional exponents by rewriting it as a radical. So to rewrite this as a radical, we write 4 underneath our radical symbol. The denominator becomes the index of our radical. And again, when our index is 2, you do not have to write it, but I'm just writing it here for clarity. And then the 5 we'll write as an exponent outside of our radical. Let's simplify inside parentheses first. The square root of 4 we can compute mentally, that would be 2, and then we need to continue to raise it to the 5th, and 2 to the 5th will give us 32. Now we're asked to simplify this expression. Again, this expression is not yet simplified because we have these powers being raised to a power. To simplify, the product to a power rule says that when you're multiplying quantities inside parentheses, you can apply this outer exponent to each of the quantities being multiplied. So be careful here. We have 3 quantities being multiplied inside the parentheses. This is 64 times a cubed times b to the 12th. So we need to make sure to apply this exponent to each of those 3 pieces being multiplied within the parentheses. Let's start by applying the 1/3 to the 64. That'll leave us with 64 to the 1/3. Then let's apply the 1/3 to the a cubed, which leaves us with a cubed to the 1/3. And then we'll apply the 1/3 to the b to the 12th, which will leave us with b to the 12th to the 1/3. Now I'm going to come back to this expression in just a minute, so I'm going to leave it as is for now. Now, when we raise a power to a power, we can simplify that by just multiplying those two powers. So this would simplify to a to the 3 times 1/3. Similarly, to simplify this, we want to multiply 12 times 1/3, which would give us b to the 12 times 1/3. And again, I'm going to leave the 64 to the 1/3 as is for now. 3 times 1/3 gives us 1, so this would simplify to a to the 1, and 12 times 1/3 gives us 4, so this would simplify to b to the 4th. Now we have one step left. Remember, if you end up with a number raised to a fractional exponent, we need to evaluate it. In other words, we need to compute the value of this. To do that, we rewrite it as a radical. So we're going to put the 64 underneath our radical symbol. The denominator always becomes the index of our radical. And when the numerator is a 1, you don't need to write it. And then we'll bring down a b to the 4th. Now, let's use the strategy we learned in 6.1 to simplify this radical. Since this is the cubed root, we want to rewrite 64 as some quantity cubed. You'll find that 4 cubed is equal to 64. Now that we've rewritten 64 as 4 cubed, this index matches this exponent, so they cancel because the cubed root and the cubed power are inverse operations. They cancel each other out. So if we cancel the cubed root and the cubed power, all that we're left with is 4, and then we'll bring down the a, b to the 4th. Let's take a look at this example. Now the instructions are still to simplify, and I notice a few issues here. The base x appears more than once, and the base y appears more than once. So we need to fix that. In addition, we have a negative exponent, and we also have powers being raised to a power. So there are lots of things we need to simplify here. And for these problems, there are often more than one way you can go about solving them. I'm going to start by focusing on this numerator here. Even though I see a negative exponent here, I like to wait till the end to fix the negative exponent because sometimes if you fix it right away, it can make the problem more complicated. So I'm going to use the product to a power rule, which says that we can apply this exponent to each of the quantities being multiplied inside the parentheses. Let's start by applying the 5 to the 2 to give us 2 to the 5th. Then let's apply the 5 to the x to the negative 1 to give us x to the negative 1 to the 5th. Then we'll apply the 5 to the y to the 2/5 to give us y to the 2/5 to the 5th. And for now, I'm just going to carry down the denominator. Now, 2 to the 5th gives us 32. When we raise a power to a power, we multiply. So negative 1 times 5 will give us x to the negative 5th. Here again, we raise a power to a power, so we multiply. So we'll keep the base. And then when we multiply 2/5 times 5, we can picture this as 5 over 1. And then if we multiply the numerators, that'll give us 10. And if we multiply the denominators, 5 times 1 will give us 5. And then I'm going to keep bringing down the denominator. Now 10 divided by 5 gives us 2. So I've just rewritten y to the 10/5 as y squared. Now, notice we have a y squared in the numerator and a y squared in the denominator. So we can cancel y squared. That will leave us with 32x to the negative 5th over x squared. Now, there's two ways we could proceed to solve this. For the first method, I'm going to start by just copying down this 32. Then I'm going to focus on x to the negative 5th divided by x squared. The quotient rule says that when you're dividing two quantities with the same base, we keep the base and we subtract the exponents. So we'll take negative 5 and subtract 2. And that will leave us with 32x. And negative 5 minus 2 will give us negative 7. Now, we've almost completely simplified, but we have a negative exponent. So we need to rewrite this expression using positive exponents. Now, this negative exponent only applies to the x. It does not apply to the 32. So when we rewrite this using positive exponents, we keep the 32 in the numerator. And since this negative exponent only applies to the x, it's only the x that we're moving to the denominator. So we're going to pick this up and move it to the denominator. And when we do, that exponent becomes a positive 7. Let's take a look at the other method we could have used to simplify this expression. Instead of waiting till the end to fix the negative exponent, we could have rewritten this negative exponent using a positive exponent right away. Again, this negative exponent only applies to the x, not the 32. So to rewrite this using positive exponents, I'm going to keep the 32 exactly where it is, and I'll keep the x squared exactly where it is. And the x has the negative exponent, so I'm going to pick this x up and move it to the denominator, which will give us x to the positive 5 in the denominator. Now, I'm going to keep the numerator as is. And in the denominator, we can use the product rule, which says when you multiply two quantities with the same base, we keep the base and add the exponents. So we'll take 2 plus 5. And that will simplify to 32 over x to the 7th, which is the same answer we got over here. Let's take a look at another example. Now, a very common mistake here is that students will FOIL because a lot of us are programmed so that if we see two sets of parentheses, we want to FOIL. But remember, you only FOIL if you see addition or subtraction symbols inside your parentheses. So if these two multiplication symbols were addition or subtraction symbols, then we would FOIL. But if there aren't addition or subtraction symbols inside your parentheses, you do not FOIL. In fact, all that's going on here is multiplication. So I'm going to rewrite this in an equivalent way as r to the negative 1/3 times s times r to the 1/2 times s to the negative 4/3. We don't need these parentheses, they just imply multiplication. Now, with multiplication, we can use the commutative property, which says that we can rearrange these pieces in any order. And when we multiply like quantities. So I'm going to move these r's next to each other. So I've put r to the negative 1/3 right next to r to the 1/2. Let's also put the s's right next to each other. So I've written s right next to s to the negative 4/3. That helps us because, again, when we multiply, we want to multiply like quantities. So we're going to multiply these r's together, and we're going to multiply these s's together. When we multiply two quantities with the same base, we keep the base, which is r in this case, and we add the exponents. So I've added the exponent negative 1/3 to the exponent 1/2. Let's do the same with the s's. Again, when we multiply two quantities with the same base, we keep the base, which is s in this case, and we add the exponents. The implied exponent here is a 1, so we'll take 1, and then we'll add this exponent negative 4/3. Now we want to simplify. We'll keep the base, and you can either add negative 1/3 plus 1/2 by hand by getting a common denominator, or you can use your calculator. Either way, if you take negative 1/3 plus 1/2, we get 1/6. If you take 1 plus negative 4/3, we get negative 1/3. Now, these have different bases, so we can't multiply or combine these any further, but we do have a negative exponent that we need to fix. So we can picture this whole expression as being over 1. So to fix this negative exponent, we want to pick this up and move it to the denominator. That will leave us with r to the 1/6 in the numerator, and when we move this to the denominator, it becomes s to the positive 1/3. Now remember, if you end up with a number raised to a fractional exponent, you want to evaluate it, or in other words, find the value of it by rewriting it as a radical. But if you end up with a variable raised to a fractional exponent, you can rewrite it as a radical, but that won't help you to simplify it any further. So we can stop here. For this example here, again, we're asked to simplify. I notice a couple issues here. One, the base x appears more than once and the base y appears more than once. That needs to be simplified. Also, we have a negative exponent, so that needs to be simplified as well. Before we work through this problem, I want to work through a simpler but related example. We're going to want to use the quotient rule of exponents here. The quotient rule of exponents says when you're dividing two quantities with the same base, we keep the base, which is x, and we subtract the exponents. So we took 5 and we subtracted 2. When we're dividing the y's, we keep the base, which is y, and we subtract the exponents. So we're going to take 9 minus 2. And if we simplify, this will leave us with x cubed, and this will give us y to the 7th. Now, one thing to note here, when you're using the quotient rule, you'll start off with something in the numerator and something in the denominator. Your answer, though, will only go in the numerator. So when you're applying the quotient rule, you write your answer in the numerator. Now let's take a look at this problem here. I've started by copying this exact original problem here. I've just color-coded it a bit. Now, just like we did over here, we can apply the quotient rule of exponents here. We'll leave the 8 alone in the denominator for now. When we're dividing these x's, the quotient rule tells us to keep the base, and we put that base in the numerator, and then we subtract the exponents. So we'll take 2/3, and we'll subtract 1/2. Let's do the same with the y's. We keep the base, and we subtract the exponents. So we'll take -1/3 and subtract 5/3. Okay, I'm going to start by just leaving the 8 in the denominator, and then let's simplify these expressions here. I'm going to use my calculator to help. So for here, we'll keep the x, and then we want to take 2/3 minus 1/2. You'll get 1/6. Then we'll keep the base y, and then if you subtract either by hand or using your calculator, -1/3 minus 5/3 will give us a -2. Now, there's still one more thing we have to simplify. When we simplify, we do not want negative exponents, so we want to rewrite this using positive exponents. To do that, let's pick up this y and move it to the denominator. So I'll leave the 8 where it is and the x to the 1/6 where it is. And then we're picking up this y to the -2 and moving it to the denominator, which will give us y to the +2. And now this is fully simplified. This last page asks us to rewrite each of the following radicals using rational exponents and then to simplify. So to follow these instructions, we're going to rewrite this using rational exponents. In other words, using fractional exponents. Remember, any radical can always be rewritten using rational exponents. The 9 will be the base. The index goes in the denominator of our fraction, and this exponent goes in the numerator. Now, 3/6 can be reduced to 1/2. Now, we've rewritten this using rational exponents. Now we want to simplify. How do we simplify an expression like this? Well, remember, when you have a number raised to a fractional exponent, we want to evaluate it by writing it as a radical. To do that, we put the 9 underneath the radical. The denominator becomes the index of our radical. And again, when the index is a 2, you technically don't have to write it. And when the numerator is a 1, you don't have to write it. So now we're left with the square root of 9, which simplifies to 3. So this was an interesting problem because we started with a radical, and then we rewrote the radical using a fractional exponent. And then to simplify this expression, we had to rewrite it in radical form. Let's take a look at this example. Again, to follow the instructions, we want to rewrite it using rational exponents. Let's start with the 4th root of x. To rewrite this using rational exponents, x is our base, and the index always goes in the denominator of our fraction. Here we had an exponent, which we put in the numerator of our fraction. Here, since there's no exponent, we just put a 1 in our numerator. Then for the cubed root of x will be our base. The index always goes in the denominator of our fraction, and again, the numerator here will be 1. Now, can we simplify any further? Yes, because remember, when simplifying, each base should occur only once. The base x here occurs more than once, so we need to simplify. And to simplify this, we can use the product rule of exponents, which says when you're multiplying two quantities with the same base, we keep the base and add the exponents. So we'll take 1/4 plus 1/3, and then to simplify that, 1/4 plus 1/3 will give us 7/12. Now remember, if you end up with a number raised to a fractional exponent, you want to rewrite it as a radical to see if you can evaluate it. If you end up with a variable raised to a fractional exponent, you can rewrite it as a radical, but it won't help you to simplify it any further, so we can just stop here. And let's take a look at this last example. First, we'll rewrite it using rational exponents. To rewrite the square root of x using rational exponents, we'll start with x as our base. When there's no index written, you can always assume that it's a 2. So since the index is a 2, that goes in the denominator of our fraction, and then the numerator will be 1. Then let's focus on this denominator. We'll start by writing x as our base. Since the index is a 5, that goes in the denominator of our fraction, and this exponent 4 will go in the numerator of our fraction. Now we've rewritten this using rational exponents, but we still need to simplify because the base x should appear only once when it's fully simplified. To simplify this, we can use the quotient rule of exponents, which says when you're dividing two quantities with the same base, you keep the base, and then we subtract the exponents. So we'll take 1/2 and subtract 4/5. Now, 1/2 minus 4/5 equals -3/10. Now, we're not quite simplified because we now have a negative exponent. So to fully simplify this, we need to rewrite it using positive exponents. And to do that, we're going to pick this up and move it to the denominator. That will give us 1 over x to the positive 3/10.